In this video, let us continue to solve problems based on surface areas and volumes. The problem reads like this. A solid sphere of radius 3 centimeters is melted and then cast into small spherical balls, each of diameter 0.6 centimeter. Find the number of balls thus obtained. So what's this problem all about? How are we supposed to solve it? Well, I'll just give you a brief outline, of the problem, like how are you going to solve this. You just need to know the volume that is being melted. So that volume should be the same when you find the total volume of the balls, right? So all you have to do is find the volume of each ball and divide the total volume by the volume of each ball, and then you get the number of balls. That's all. It's pretty simple. All right. Say for example, you've got a football and then you want to make some little tennis balls out of it. The volume is going to be equal at the end, right? Only the number of balls vary. So that's how it is. So yeah. So here, let's assume that let the total number of balls be x. Right? Now we need to find the volume of the solid sphere. Volume of the solid sphere is given by 4 by 3 pi r cube, right? So now it is 4 by 3 times pi is 22 by 7, and the radius is given as 3 centimeters. That is 3 times 3 times 3. You've got a 3 and 3 gets cancelled. And then solving this, you get, we've got 3 times 3 is 9, 9 times 4 is 36. Now let's take this 22 by 7 as pi itself. Let's give it as pi. So we've got 36 pi centimeter cube. So this is the volume of the solid sphere, right? So now the radius of each ball is going to be half of the diameter, right? So radius of spherical ball equals 0.6 by 2 centimeters. So that is going to be 0.3 centimeters. So now the volume of this spherical ball is going to be, so the volume of this spherical ball is going to be 4 by 3 pi r cube. R is 0.3, right? So 0.3 cube centimeter cube. Now solving this, we again get almost 36 pi by 1000 centimeter cube, right? So this is going to be the volume of one spherical ball, right? It's going to be the volume of one spherical ball. So what is the volume of x spherical balls going to be? You just have to multiply x to this. If one spherical ball is so much, if the volume of one ball is so much, then the volume of x spherical ball is going to be 36 pi by 1000 times x. That's all. So now let's find out the volume of x number of spherical balls. And that's going to be 36 pi by 1000 x centimeter cube. Now what we have to find is the number of balls, right? And the volume should be equal. This 36 pi centimeter cube should be equal to this volume, the total volume. So let's equate this and find out x. So we've got 36 pi by 1000 times x equals 36 pi. So 36 pi gets cancelled. So x equals 1 times 1000. If 1000 goes to the right hand side, it should be 1 times 1, which is 1000. So therefore, 1000 number of balls can thus be obtained by melting a solid sphere of radius 3 centimeters. So that's all this problem is all about. Pretty simple, you know that the volume should be equal. That's the main hint here. The volume should be equal. So just equate the volume and find the unknown. And then you get the answer. So let's quickly solve another problem in this video. Alright, so we've got another problem. A conical vessel whose internal radius is 5 centimeter and height 24 centimeter is full of water. So immediately you know what is the volume of water that is present in this vessel, right? So that's no problem. Now this water is emptied into a cylindrical vessel with internal radius 10 centimeters. We need to find the height to which the water rises. So definitely if the same amount of water is going to be emptied into a cylindrical vessel from this conical vessel, only the shape is going to change. The volume is not going to change, right? So you just need to know the volume of conical vessel and then the volume of a cylindrical vessel. Equate them, equate the volumes of both these vessels and find the unknown. The unknown here is the height. So h is going to be the unknown. So find that. So it's again a very similar problem to all the problems that we've done. It's just, given in a different way. So let's solve this. So now let's have R1 as equal to the radius of the conical vessel. Which is equal to 5 centimeter. Then we've got H1. Let that be H1. So that is the height of the conical vessel, which is already given in the question. So no doubts about that. So that height of the conical vessel is going to be 24 centimeter. And then we've got R2, which is radius of the cylindrical vessel, right? That's also given in the question, part of the data that we already have. So that's 10 centimeters. Right now, let us take the height of the cylindrical vessel as H2, which is what we have to find. That's the height up to which the water is going to rise once you empty it from the conical vessel in which the water is already present. So now, the most important statement is volume of water in conical vessel is equal to volume of water in cylindrical vessel, right? So what is the volume of cone? What is the volume of a cone? That is 1 by 3 pi r square h. So in that case, it's r1 square, right? Then we've got h1 because that's the volume, that's the notation that we've given. So the volume of water in the cylindrical vessel is going to be pi r2 square h2, right? So now we've got pi and pi cancelling each other. So all we're left with is r1 square h1 equals, let's shift 3 to the right hand side. So we're going to get 3 times r2 square h2, right? So now we've got the data here. So let us write it. So we've got R1 as 5 centimeter, right? So it's 5 square. So 5 times 5 into H1 as 24 equals 3 times R2 squared is R2 is 10. So 10 times 10. We don't know H2. H2 is what we have to find. So H2 is unknown. So H2 equals. So H2 equals 5 times 24 divided by 3 times 10 times 10. You just have to like push this or get H2 this side. So yeah, if you keep H2 here, so this is going to go down, right? So you're just going to interchange and write that. So H2 equals 5 times 24 divided by 3 times 10 times 10. So H2 equals on solving, we get this goes 3 times 8 and 5 goes 2 times and 10, 2 times and 10. So 2 goes 4 times, 2 goes 2 times. So you're going to get 2 centimeters. So yeah, here it is. So hence the height of the water in the cylindrical vessel is going to be 2 centimeter, or the height to which the water is going to rise is going to be 2 centimeter, no less than 2 centimeter or no more than 2 centimeter if the volume of the water is not changed. But if you increase it, obviously the height is going to go up. If you decrease the water, the height is definitely going to go down, right? So that's all there is to do in this problem. I'll see you in the forthcoming videos with more problems based on surface areas and volumes.